This is SpaceTime, Series 29, Episode 1, for broadcast on the 2nd of January 2026. Coming up on SpaceTime, cosmic matter spotted travelling at 20% the speed of light, studying wind-sculpted landscapes on the red planet Mars, and could there be a vast ocean under the surface of Uranus's moon Ariel? All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have observed a sudden outburst of matter near a supermassive black hole shooting out into deep space at some 20% the speed of light. The findings, reported in the journal Astronomy and Astrophysics, are demonstrating a new way of powering these superluminal jets. Astronomers were studying the supermassive black hole at the centre of NGC 3783, a barred spiral galaxy some 135 million light-years away in the constellation Centaurus. During a 10-day observational run, primarily using NASA's XRISM space telescope, astronomers witnessed powerful outbursts of matter being ejected. Now, they often find that these outbursts are powered by strong radiation. But this time, the most likely cause isn't radiation, but a sudden change in the magnetic field, similar to bursts on the Sun caused by solar flares. While supermassive black holes are known to flicker in X-rays, this is the first time astronomers have clearly seen a high-speed ejection accelerated during an X-ray burst. During this 10-day period, scientists saw variations in X-ray brightness and intensity, especially in the softer X-ray bands. Now, these changes, including the outburst that lasted for 3 days, aren't unusual for supermassive black holes. However, what makes this event so unique is the simultaneous ejection of gas from the accretion disk of swirling matter orbiting the black hole. This gas was expelled at incredibly high speeds, reaching some 60,000 kilometers per second. That's 20% the speed of light. The gas appeared to originate from a region at a distance roughly 50 times the size of the black hole itself. In this turbulent region, gravity and magnetic forces interact in extreme ways. The authors believe the ejection was caused by a process called magnetic reconnection, the sudden reconfiguration of magnetic fields releasing huge amounts of energy in the process. The study's lead author, Lai Gu from the Netherlands Institute of Space Research, says these observations are providing a unique opportunity to study the launch mechanism for ultra-fast outbursts. The data suggests that the acceleration of the outflow is being driven by magnetic forces similar to coronal mass ejections from the Sun. Now, coronal mass ejection from the Sun happens when large blobs of hot plasma and magnetic field are hurled into space during a solar flare event. And a supermassive black hole can do the same, only the eruptions are tens of billions of times more powerful, dwarfing anything ever seen blasting out from our Sun. Gu and colleagues proposed that the observed black hole event, just like its solar counterpart, is being fueled by sudden bursts of magnetic energy. But that contradicts the hypothesis that black holes expel matter through intense radiation or extreme heat. The results therefore offer new insights into how black holes not only pull matter in, but under the right conditions can also shoot it back out again into space. The process has been dubbed feedback, and it may play a key role in how galaxies grow and change over time, influencing the stars and gas around the black hole and helping shape the universe as we see it today. This is SpaceTime. Still to come, studying the wind-sculpted landscapes of the red planet Mars. And could there be a vast ocean under the surface of Uranus's moon Ariel? All that and more still to come on SpaceTime. While much of NASA's Mars Perseverance rover's work focuses on ancient rocks that record the red planet's long-lost rivers and lakes, megaripples are offering a rare opportunity to examine processes which are still shaping the Martian surface today. Megaripples are sand ripples, some up to 2 meters tall, that are mainly built and modified by wind. However, when water in the atmosphere interacts with dust on the ripple surface, a salty, dusty crust can often form. And when this happens, it's much harder for the wind to move or reshape the megaripple. As such, megaripples on Mars are largely considered inactive, standing as records of past wind regimes and atmospheric water interactions over time. However, some have shown signs of movement, and it's possible that periods of high wind speeds may erode or even reactivate these deposits again. Despite the thin Martian atmosphere today, which is just 2% that of Earth's atmospheric density, wind remains one of the main drivers of change on the Martian surface, eroding local bedrock into sand-sized grains and transporting these grains across the ripple field. As a result, megaripple studies can help scientists better understand how wind reshapes the Martian surface, how it changes the planet's recent history, and in the process it'll help scientists plan for future human missions to the Red Planet, because the chemistry and cohesion of Martian soils will influence everything that people do on Mars, from mobility through to resource extraction. Following the successful investigation of the dusty inactive megaripple at Kerr Laguna, the car-sized Perseverance rover, which is travelling along the rim of Jezero crater, has now begun exploring a new, more expansive field of megaripples known as Honeyguide. This region boasts some of the largest megaripples ever seen along the rover's journey so far. That makes it an ideal location for a comprehensive study of these features. The megaripples at Honeyguide are larger and extend further and have sharply defined crests with more uniform orientation compared to those at Kerr Laguna. The consistent orientation of the megaripples at Honeyguide suggests that the winds in this area have been blowing predominantly from the same direction, that's north to south, for a long period of time. At Honeyguide, Perseverance has been studying the Hazy View megaripple, where more than 50 observations have now been taken, looking for grain movement, signs of early morning frost, and for changes in mineralogy from crest to trough. The investigation of the Hazy View bedform builds directly on the results from Kerr Laguna and represents the most detailed study yet of these intriguing wind-formed deposits. This is SpaceTime. Still to come, could there be a vast ocean deep under the surface of Uranus's moon Ariel? And planet Earth reaches perihelion, Sirius the brightest star in the night sky, the missing constellation of Argo Navis, and the Quadrantids meteor showers are among the celestial highlights of the January night skies on Skywatch. There's growing evidence suggesting that a vast subsurface ocean could be lurking beneath the icy surface of Uranus's moon Ariel. The findings, reported in the journal Icarus, looks at the possible evolution of this ocean, finding that it may once have been more than 170 kilometres deep. Now, by comparison, Earth's largest ocean, the Pacific, averages just 4 kilometres in depth. One of the study's authors, Alex Padoff from the Planetary Science Institute, says Ariel is unique in terms of icy moons. It's the brightest and second closest moon to Uranus, and at just 1,159 kilometres in diameter, it's the fourth largest moon in the entire Uranian system. From the little astronomers can see, it has some very old geological features, like craters, which are right next to some very young features, like smooth terrain of the type possibly created by cryovolcanism. Ariel has fractures, ridges and graben, that's crust that's dropped lower than its surroundings, and it has these at scales larger than almost anything anywhere else in our solar system. It's this dramatic landscape that has prompted the study. The authors want to understand Ariel's past interior structure as well as its orbital eccentricity, that is how much the moon's orbit deviates from circular, which would help define how features on Ariel's surface have evolved today. Both characteristics can contribute to how much stress can be applied to the surface, causing it to fracture under the push and pull gravity that's exerted on the small moon as it orbits around its ice giant host. To work out what's going on, the authors first mapped out the large structures which they're able to see on the moon's surface. They then used a computer program to model the tidal stresses on the surface, which result from the distortion of Ariel from a soccer ball-shaped object to a slightly more elongated rugby league or gridiron-shaped ball, which then moves back to a round soccer ball shape and back to an elongated shape as it moves closer and further from Uranus during its orbit around the planet. Pladoff says by combining the model with what can be seen on the surface, he and his colleagues were able to make some inferences about Ariel's past eccentricity and how thick the ocean beneath the surface must have been. They found that in the past, Ariel needed to have an eccentricity of about 0.04. That's about 40 times higher than its current value. While 0.04 may not sound very dramatic, eccentricity can strengthen the effects of tidal stresses, and Ariel's orbit would have been 4 times more eccentric than that of Jupiter's moon Europa, which is racked by tidal forces pushing and pulling on it, creating its cracked and broken surface. Padov says in order to create these fractures, the body has to have either really thin ice on a really big ocean or a higher eccentricity and a smaller ocean. But either way, one still needs an ocean to create the sorts of fractures seen on Ariel's surface. These new findings represent the second in a series of studies investigating the moons of Uranus. Back in 2024, the same set of authors published a paper on Miranda with similar results. Of course, the problem is astronomers have only seen the southern hemispheres of both Ariel and Miranda. Ultimately, astronomers will need to send a mission there, studying the Uranus system in order to find out what's really going on. This is SpaceTime. And time now to turn our eyes to the skies and check out the celestial sphere for January on Skywatch. January is the first month of the year in the Julian and Gregorian calendars. The name originates in the Latin word for door. That's because January is the door to the new year and an opening to new beginnings. The month is conventionally thought of as being named after Janus, the mythical Roman god of beginnings and transitions. But according to the ancient Roman farmer's almanac, it was actually Juno who was the traditional god of January. Of course, from an astronomical point of view, January marks Earth's closest orbital position to the Sun, perihelion, which occurs about 2 weeks after the December solstice. Planets, including the Earth, don't orbit the Sun in perfect circles, but rather in ever-changing elliptical orbits. The shape of these orbits vary due to gravitational influences from other planetary objects. And in Earth's case, that especially includes the Moon, which is almost massive enough to be considered a binary partner. So, over a roughly 100,000-year cycle, Earth's orbit changes in shape from almost circular to far more elliptical. This difference is known as eccentricity, and the nearest point in Earth's orbit around the Sun is called perihelion. This year, perihelion will occur on Sunday the 4th of January at 4:15 in the morning Australian Eastern Daylight Time. That's when the Earth will be just 147,099,894 kilometres from the Sun. That's 12:15 in the afternoon of Saturday, January the 3rd, US Eastern Standard Time, and 5:15 in the afternoon of January the 3rd, Greenwich Mean Time. Around 6 months later, and about 2 weeks after the June solstice, Earth will be at its furthest orbital position from the Sun, a location known as aphelion. Okay, let's start our tour of the January night sky by looking to the northeast, right next to the constellation Orion, where you'll see the brightest star in the night sky, the dog star Sirius. So called because it's the brightest star at the constellation Canis Major, the big dog. The name Sirius actually means scorching or brilliant, a clear reference to its spectacular brightness in the sky. As well as being one of the nearest stars to the Sun at just 8.7 light years, it's also intrinsically bright, and almost twice as bright as the second brightest star in the night skies, Canopus. A light year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. Sirius is the 5th closest star to the Sun, and it's gradually moving closer to the solar system, so it'll steadily increase in brightness over the next 60,000 years. After which time it will begin moving away again, and it will gradually become fainter and fainter. But it will still continue to be the brightest star in Earth's night sky for at least the next 210,000 years. Sirius is a binary star system comprising a spectral type A main sequence white star called Sirius A and a small white dwarf companion Sirius B, which orbits between 8.2 and 31.5 astronomical units away from the primary star. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres. Main sequence stars are those undergoing hydrogen fusion into helium in their core. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue white stars, then spectral type A white stars, spectral type F whitish yellow stars, spectral type G yellow stars, that's where our sun fits in, spectral type K orange stars, and the coolest and least massive stars known are spectral type M red stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together and our Sun becomes a G2V or G25 yellow dwarf star. Also included in the spectral classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest stars, those spectral type M red dwarfs we talked about before, which are about 75 to 80 times the mass of Jupiter, or around 0.08 solar masses. Brown dwarfs don't have enough mass to build up the sorts of temperatures and pressures in their cores needed to trigger the nuclear fusion process which makes stars like our Sun shine. Sirius A has at least twice the mass of the Sun and is about 25 times more luminous. The Sirius binary system is between 200 and 300 million years old, quite young by astronomical standards, and it originally consisted of 2 bright spectral type A white stars. The more massive of these 2 stars, Sirius B, consumed its resources and became a red giant before shedding off its outer layers and collapsing into its current state as a white dwarf around 120 million years ago. A white dwarf is the stellar corpse of a Sun-like star. Having used up its nuclear fuel supply, fusing hydrogen to helium in its core, it expands into a red giant as it fuses helium into carbon and oxygen. Now, bigger stars can fuse progressively heavier and heavier elements, but low-mass stars like the Sun simply aren't big enough to fuse carbon and oxygen into heavier elements, and so they turn off. Their outer gaseous envelope separates and floats off into space as a spectacular object called a planetary nebula. What's left behind is a super-dense white-hot stellar core about the size of the Earth called a white dwarf, which will slowly cool down over the eons of time. Our Sun will become a white dwarf in about 7 billion years from now. 5,000 years ago, the ancient Egyptians looked at Sirius and they saw it as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Anubis was later replaced in Egyptian mythology by Osiris as the lord of the underworld, and Sirius became the goddess Isis. By carefully watching Sirius's movements across the sky, the ancient Egyptians determined that it would be visible every night for 295 and a quarter nights, followed by 70 nights of absence. And this allowed them to determine that a year was 365 and a quarter days long. Their calculations were accurate to within 11 minutes. The helical rising of Sirius also marked the annual flooding of the River Nile in ancient Egypt and the hot, sultry dog days of summer for the ancient Greeks. In Greek mythology, Sirius was the dog star and the canine companion of Orion the hunter. Helical rising refers to the first time of the year when a star becomes visible above the eastern horizon for a brief moment just before sunrise. It's been claimed that the Dogon people in Mali in Western Africa have ancient stories describing the 50-year orbital period of Sirius and its companion white dwarf, which predate the white dwarf's discovery by modern astronomers. It's also claimed that these legends were handed to the Dogon people by ancient aquatic space travelers who told them of a third star accompanying Sirius A and B. However, a report in the journal Current Anthropology raised serious doubts about whether the stars referred to by the Dogon people were in fact Sirius A and its white dwarf companion. That's because senior Dogon claim the story actually refers to a different grouping of stars. Also, other researchers have pointed out that the Dogon could have heard about the discovery of Sirius's companion and then simply incorporated it into their mythology in 1893 when a French expedition arrived in central West Africa to observe an April 16 total eclipse and were overheard discussing the discovery. Looking due north just above the horizon this time of year, and you'll see the bright yellowish star Capella, the brightest star in the constellation Auriga the Charioteer. Capella is the Latin term for a small female goat. The star's alternative name is Capra, which was more commonly used in classical times. Although it appears to be a single star to the unaided eye, Capella is actually a system of 4 stars in 2 binary pairs. The first pair comprises 2 bright yellow giant stars, both of which are around 2.5 times the mass of the Sun. Having exhausted their core hydrogen supplies, both stars have cooled and expanded out to become giants, moving off the main sequence. Designated Capella AA and Capella AB, they're in a very tight circular orbit, some 0.76 astronomical units apart, orbiting each other every 104 Earth days. Capella AA is the cooler and more luminous of the two, with some 78 times the luminosity and 12 times the radius of the Sun. Known as an aging red clump star, Capella AA is fusing helium into carbon and oxygen in its core. Capella AB is a slightly smaller but hotter subgiant, about 73 times as luminous and almost 9 times the radius of the Sun, and it's in the process of expanding out to become a red giant. The Capella system is one of the brightest sources of X-rays in the sky, thought to come primarily from the corona of the more massive giant. The second pair of stars in Capella are located about 10,000 astronomical units from the first pair. They consist of 2 faint, small, relatively cool spectral type M main sequence red dwarf stars. The 2 red dwarfs have been designated Capella H and Capella L. Now, almost directly overhead this time of year, a position in the sky known as zenith, we find Canopus, the second brightest star in the night sky after Sirius. Located some 313 light-years away in the constellation Carina the Keel, Canopus looks incredibly bright because it is huge. It's a giant spectral type A white star, with some 10 times the mass, 71 times the diameter, and 10,000 times the luminosity of the Sun. Canopus is another bright X-ray source, also most likely produced by its corona, magnetically heated to several million Kelvin. The temperature is also likely to be stimulated by fast rotation combined with strong internal convection currents percolating through the star's outer layers. No star in our night sky closer than Canopus is more luminous than it, and it's been the brightest star in Earth's night sky during 3 different epochs over the past 4 million years. Other stars appear brighter only during relatively temporary periods, during which they're passing the solar system at much closer distances than Canopus. About 90,000 years ago, Sirius moved close enough that it appeared to be brighter in our night sky than Canopus, and as we mentioned earlier, that'll remain the case for another 210,000 years. But in 480,000 years from now, Canopus will once again be the brightest star in the night sky, and it will remain so for a period of about 510,000 years. In Greek mythology, Canopus was a helmsman and the navigator for the fleet of Menelaus, king of Sparta, which was sailing back from the Battle of Troy. Canopus is said to have died when the fleet arrived at the port of Alexandria in Egypt, and so a star which was visible on the horizon was named in his honour. Now, as we said, it's the brightest star in the constellation Carina, which represents the keel of the boat Argo, used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Pappus. Combined, Carina, Vela and Pappus used to form the constellation Argo Navis, representing the ship Argo skimming along the river of the Milky Way. But modern-day astronomers consider the constellation simply too big, as it was 28% larger than the next largest constellation and had more than 180 easily visible stars. So it was divided into 3 smaller constellations, Carina, Vela and Pappus, in 1755. Canopus forms part of the stellar association or asterism known as the False Cross, which straddles the constellations Carina and Vela themselves and is often confused with the real Southern Cross or Crux. This time of the year, the Southern Cross is upside down and low down in the southern skies during the early evening. For our listeners north of, say, Brisbane, it'll most likely be hidden by trees and buildings on the horizon during the early evening. But later on, as the Earth turns, the Southern Cross will rise above the horizon in the south-southeast for our northern listeners and appear to be lying on its left side. One of the best things about living in the southern hemisphere is that most of the brightest stars in the night sky are visible during January nights. Sirius the dog star is the brightest, followed by Canopus the navigation star. Third brightest is Alpha Centauri, the furthest of the two pointer stars pointing to the Southern Cross and the nearest star system to the Sun. The fourth and fifth brightest stars, Arcturus and Vega, aren't visible in the Southern Hemisphere during January. But the sixth brightest, Capella, is visible just above the northern horizon. And the seventh, Rigel, marks Orion's knee. Next, in eighth place, is Procyon the little dog. And ninth is Achernar, at the end of the river Eridanus. Finally, there's Betelgeuse, Orion's shoulder, the 10th brightest star in the night sky. So, that's 8 of the 10 brightest stars in the night sky, all visible at once on a warm summer's evening in the southern hemisphere. January also plays host to one primary meteor shower, the Quadrantids. Most meteor showers radiate out from a recognisable constellation, like Leo's Leonids or Gemini's Geminids or Orion's Orionids. But the Quadrantids are meteors that appear to radiate out from the location of the former Quadrans Muralis constellation. In the early 1920s, the International Astronomical Union divided the sky into 88 official constellations. However, that means more than 30 other historical constellations didn't make the cut. The Quadrans Muralis area of the sky falls within the boundaries of the official constellation Bootes. The radiant point of the shower is near the Big Dipper, between the end of the handle and the quadrilateral of stars marking the head of the constellation Draco. The Quadrantids are usually one of the year's most spectacular meteor showers. They're best seen from the northern hemisphere, and unlike other meteor showers which tend to peak for at least a day or two, the Quadrantids only peak for a couple of hours. While most meteor showers are produced by the Earth passing through debris trails left behind by comets, the Quadrantids are one of only 2 meteor showers known to be produced by asteroids. They're associated with the asteroid 2003 EH1, which is thought to be the remains of a cometary nucleus that fragmented and broke apart centuries ago. EH1 still circles the Sun in a 5.5 Earth-year-long elongated comet-like orbit which extends out beyond Jupiter. The progenitor is thought to be the comet C1490Y1, which was first observed by Chinese, Japanese and Korean astronomers 500 years ago. It was classified as an asteroid when it was discovered by a near-Earth asteroid telescopic survey in 2003. The only other major meteor shower associated with an asteroid are the Geminids, which occur in December and are caused by debris left behind by the asteroid 3200 Phaeton, which is also thought to be the remains of a comet. And joining us for the rest of our tour of the January night skies is senior science writer and Sky Telescope magazine contributor Jonathan Nally.
G'day, Stuart. Well, it's summertime where I am. It's right in the middle of summer, in fact, so it's really, really warm. Our friends up in the northern hemisphere, of course, it's right in the middle of winter up there, so it's probably really, really cold where a lot of people are listening from, but it doesn't really matter. We've got great stuff to see up in the night sky, whether you have to rug up and stay warm or try and cool down a little bit as we do here in Australia. So let's begin with the evening sky for January. But we've got, for us down here, of course, in the south, we've got the Southern Cross. It's actually still more or less upside down at the moment and still low down on the southern horizon for most people, around about mid-southern latitudes or so. The further south you go, it's a little bit higher in the sky, so you can definitely see it. But if you're in the northern states of Australia, for instance, then you're not going to see the Southern Cross in the early evening because it's down below the horizon. But as the Earth turns, things rise in the east and they go down in the west, so the Southern Cross starts to make its appearance. It starts to rise in the south-southeast. And so getting towards midnight or so, you can definitely see the Southern Cross there. They're flying on its left-hand side. It looks a bit like a kite. Imagine a kite flying in the sky. You sort of do to join the dots of the corners of the kite. That's the shape of the Southern Cross. And it's quite small too. It's actually the smallest of all the constellations. So people do understand it, I suppose, because I've heard about the Southern Cross and how prominent it is. They expect to see this huge thing in the sky, but it's actually really tiny. But once you spot it, you never unsee it. You can never lose it again, really. Although I'll come back to that in a little bit. There is a little trap here for some people. What's next? The Milky Way. The Milky Way, right, which is our galaxy seen from the inside. Now, the Milky Way is just stretching right across the sky from the south to the north, or north to south, as the evening begins in January, and its star field just contains some superb constellations and deep sky objects, because we're looking into the main part of our galaxy, so there's it's very populated with things. And starting in the south, as we said, there's the Southern Cross, or Crux as it's formerly known. Then moving along, we've got the constellations of Carina and then Vela and Puppis, and then we get to most people have never heard of these, but they're real constellations. Then we get to Canis Major, and then we end up in the north with, we've got Orion and Gemini and Taurus and whole bunch of others as well. And all of those constellations have some amazing star fields, some star clusters and nebulae, a lot of which can be spotted just with a pair of binoculars, But a telescope will bring out a lot more detail, even a small telescope, because of the magnification you can get. I mentioned Carina, and this constellation Carina, it's a far southern constellation. It has the famous Carina Nebula. It's a huge gathering of nebulosity and stars. There's a big nebula in Orion, the Great Nebula of Orion, which everyone in astronomy is very familiar with, but a lot of people say that this one in Carina is better than the one in Orion. It's just that there are fewer people see it down here in the south. When I say nebulosity, by the way, too, nebulosity just means gas and dust clouds. Constellation Vela. Now, this is the one I was talking about getting confused with the Southern Cross, because it has a bunch of stars, these 4 stars, that do make exactly the same shape as the Southern Cross, and it's not far enough from the Southern Cross, but this false cross, as it's called, is much, much bigger. It's really big, and a lot of people spot it first and think, oh, I've seen the Southern Cross. Some of them probably never realised they've made the mistake, but others will later on realise, oh, hang on, that's the false cross. I mentioned Orion before, so the Great Nebula. The Great Nebula of Orion, if you've got really good eyesight and you're in a really dark spot with no lights around and you've let your eyes dark adapt and you use what's called averted vision, so you don't look directly at the thing, you sort of look out the corner of your eye, you can just make out a smudge of light. That is the Great Nebula of Orion. If you're in the city, you've got no hope really, but if you're out in the dark country skies, you can see it. But it look really, really good. And when you compare that with a picture in a book or a magazine or online, and you realise what you're seeing, and you can actually see this with your eyes with a bit of help from a telescope, it really is quite awe-inspiring, I think. Orion's also got these 2 bright stars, Rigel and Betelgeuse, and 3 stars right in the middle of it, sort of cutting it in half in a short straight line. 3 stars sort of spaced out equally. Very easy to spot. Taurus, I mentioned Taurus. Taurus has a fabulous wedge-shaped grouping of stars, a star cluster, and it's called the Hyades. And you can see this one with just your own eyes. You don't need a telescope. It's actually quite large, this wedge shape or triangular shaped group of stars. And also in Taurus, and more or less directly north from the southern hemisphere, if you're looking from down south in the mid to late evening this month, or you're looking from to the south if you're in the northern hemisphere, there's another tiny clump of stars in Taurus called the Pleiades, or the Seven Sisters, which we've spoken about many times in the program. It's a group of, more than 1,000 stars, quite a long way from Earth. And if you have good eyesight and you've got some dark skies, then you take a look, and most people can see 6 or 7 of these stars, so that's why it's called the Seven Sisters. Some people have claimed to be able to see 10 or 11 if they've got really good eyesight. And if you have a pair of binoculars and you take a look at this little star cluster, it looks brilliant. It really, really does. It's like these little sparkly jewels in the night sky. You don't see all 1,000 or 1,000 plus of these stars. You're only going to see a dozen or maybe 20 or whatever with a pair of binoculars, but it still looks really fantastic. It's probably the best in the night sky, I reckon, for looking at with a pair of binoculars. Now, back in the south and high up in the sky, 2 galaxies that you can see with the unaided eye, as long as you don't have too much light pollution around, such as lots of street lights. So you really do need a dark location. And these are the Small and Large Magellanic Clouds. Very famous and quite big. They're not little small things in the night sky. They're really quite large. And, if you get out into, as we would say here in Australia, the bush, get out into a remote rural area with no lights around and you let your eyes get dark adapted, you can spot these things so easily. Then they're called the Magellanic Clouds. They're named after Magellan, the explorer. So you can imagine what an amazing view he would have had out in the middle of the ocean with no lights around. And professional astronomers really like the Magellanic Clouds because they're very nearby in space terms. They're sort of neighbours of our Milky Way, and they're so close that you can actually make out individual stars through professional telescopes. The most famous thing that happened in Magellanic Clouds was a supernova back in 1987, which is called Supernova 1987A, imaginatively, a huge explosion of a star in the Large Magellanic Cloud. The light got to us in 1987, but it actually happened about 170,000 years before, because the Magellanic Cloud is about 170,000 light years away. So it took all that time for the explosion to get to us. And I remember seeing it when the light reached the Earth in, I think it was February 87. It was quite amazing. It was something that astronomers had been waiting for literally for centuries. We hadn't had a really bright supernova, one that you could just go out and see with your naked eye, for centuries. In fact, since the telescope had been invented, basically. So I remember that just every professional astronomer and every professional observatory and every amateur astronomer who could see this part of the sky just dropped everything dropped everything they were doing for months. There was an Australian astronomer who religiously took pictures of the night sky, including of that area, and in the morning he would check his pictures and develop the pictures and everything before digital cameras. He would check his pictures to see if anything had changed, like a supernova or an asteroid or something that hadn't been there the night before. And this particular morning he just slept in or thought I'll do it later, which he never used to do. And so he missed being the first one to make the discovery. How would you feel?
You'd be
That's
kicking
the way it goes.
yourself, wouldn't you?
Well, I suppose so. But look, he went on. He's discovered comets, asteroids, all sorts of things. He's made stacks and stacks of discoveries, that fellow. So he's done all right. Now, turning to the planets, as I mentioned last month, both Venus and Mars are out of view at the moment. They're lost in the sun's glare, both in the morning sky and the evening sky. And the same now goes for Mercury too. I mean, technically speaking, at the beginning of the month, Mercury just pops its head over the horizon in the sort of dawn glow. But for the average person who's not used to looking for these things, you really don't have much of a hope of seeing it, particularly as, when I say it pops its head over the horizon, that's the theoretical horizon if there were no buildings and trees and hills and everything in the way. So most people have something in the way. So you're not going to spot Mercury, unfortunately. So the only two planets visible to the unaided eye in January are still good ones. They're Saturn and Jupiter. And fortunately, both of them are up and about in the evening hours. For Saturn, after sunset, look about halfway up from the horizon in the west-northwest if you're in the southern hemisphere. So that would be west-southwest in the northern hemisphere. And you should see it. It looks like a medium brightness star. It's a planet, obviously, but it looks like a star. And it has a slightly yellowish tinge. Now, Jupiter is on the other side of the sky. It's just rising over the northeastern horizon after the sky becomes dark. It's the northeastern horizon for southern hemisphere viewers, southeastern for our friends in the north. So, yeah, just coming over the horizon after the sky becomes dark at the start of the month. It looks like a big, bright white star, and you really can't miss it because at the moment, with Venus out of sight, Jupiter is the brightest light in the night sky apart from the moon. So even though the star Sirius is also visible at the same time, Jupiter is much, much brighter than the brightest star in the night sky. So you shouldn't have any excuse for not seeing it. And that, Stuart, is the night sky for January.
That's senior science writer and Sky and Telescope magazine contributor Jonathan Nally, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.